Good evening, ladies and gentlemen, and thanks for attending this evening. I'm going to speak about Rare Earths, the company Rainbow, and what Rare Earths mean currently to the world. As you can see the quote there from Deng Xiaoping, the Chinese 30 years ago recognized the strategic value of rare earths, and they started to focus on this market, and the Chinese control this market. And we've just attended the criticals materials, the UK Critical Materials conference this morning, Peter and I. And once again, it's reinforced how strategic all these green metals are. Being lithium's one of those, but rare earths are very, very key in that. And the UK is focusing on trying to have a strategy to make them independent of China for these strategic metals. And the reason being is that they want to protect the UK car industry, the wind turbine industry, and of course jobs that go with it. So this is reinforced almost every other week in the press, and the European Union is doing a similar thing, and so is the United States. So it's a very topical point at the moment, and it's being legislated, as you pointed out earlier. So this demand is not going away. It's not like gold. Gold's a fad because everyone's worried about inflation, so people invest in gold or so forth. This is not a fad. It's been legislated. Demand has been driven by electric vehicle penetration and wind turbine penetration. And so the penetration might be slower, but the demand is not going to go away. And it's always going to be there for the next 30 or 40 years. Disclaimer, you can read that at your leisure. So just to talk about Rainbow now, we're listed here on the London Stock Exchange. We have flagship asset in South Africa called Phalaborwa, and I'll speak about that later. Very importantly, we've just released our preliminary economic assessment last month, and these numbers are phenomenal numbers for any project. Even though we're a mining company, this is not really a mining project, it's a chemical processing project, and I'll speak to that later. But we'll be generating EBITDA margin of about $200 million life of project on revenue of $260 million. And this is a phenomenal EBITDA margin, circa 75+%. Very importantly, we've got one of what I believe is the lowest OPEX cost for separated rare earth oxide, which is what we're going to be producing in Phalaborwa in South Africa. And separated rare earth oxides are quite far downstream in terms of beneficiation before you go into making metal and alloy and then magnets. And as I said, we've got unique IP which allows us to do this. And because we're going downstream, we are able to capture the full price of a separated rare earth oxide. And a lot of rare earth mining projects don't go all that way downstream. So we're one of the few projects in the world right now that are going to go all the way down there. But as I say, that price of $33.86 per kg of separated rare earth oxides, I believe, I was at the Rare Earth Conference in Las Vegas last month, and we believe that is even lower than the Chinese price of separated rare earth oxides. And the rare earth market is dominated by the Chinese, so you've always worried about whether the Chinese will drop pricing to prevent new projects coming on stream. But they're never going to drop the prices below their cost of production, and we're below the Chinese cost of production, which puts us in a unique space. And then we have a small project in Burundi, which is a trial mining operation producing a high-grade concentrate. But our focus is Phalaborwa, and that's what I'm going to talk about here. I think this slide is particularly important with junior mining and junior exploration companies. I'm sure the audience knows there's many exploration companies around the world, be them TSX listed, ASX listed, or even AIM listed, who never get into production for various reasons. So we've got a team at Rainbow with a lot of experience and a lot of success. I've been CEO of a gold exploration business called Shanta Gold. I listed here in London in 2005. It's got 2 operating gold mines, so it's been a success. I then started a mining engineering business in 2006 after I left Shanta, when I listed Shanta here. And I listed that business 2 years later in London, sold it to Amic Foster Wheeler about 6 years ago, the global engineering business. But during that time, I built 22 mines around the world and did over 40 feasibility studies. And my key technical directors from MDM are still with me at Rainbow, or have come to work for me at Rainbow. Dave Dodd's one of those key guys. Dave's designed and built over 80 process plants around the world across every mineral you can think of, and has done over 100 feasibility studies. So we've got a lot of experience on being able to take projects on behalf of clients from feasibility all the way through to production and commissioning. We're now doing it ourselves with Rainbow, and as I said, we've got lots of experience. Dave and I also, at our time in MDM, built 2 gold and uranium plants. And gold and uranium, well, certainly the uranium part of a plant, deals with continuous ion exchange and resins and metals, materials of construction, which are very similar to what you need in a rare earth plant. So all that experience in designing and building uranium plants, we have in our Rainbow team. And I think that's a key difference between us and other junior miners. And then our chairman, Adonis Prulis, very well-known mining entrepreneur with lots of successes, and Pete Gardner, my CFO, 20-odd years in project mining, financing mining projects and developing as well as operating assets. So we talk about, rare earths, why they're important. As I said, it's the key ingredient in what they call permanent magnets going into electric vehicles, wind turbines, drones, electric scooters, and your cell phone has rare earth magnets in them and so forth. But the demand being driven by wind turbines and electric vehicles now is what's pushing up rare earth prices. And the only 4 key rare earths that are important for permanent magnets is neodymium, praseodymium, and terbium and dysprosium. Our project in Pelabor has all 4 of those rare earth elements, and not all projects have all 4 rare earth elements. Fortunately, we do. As I said, demand is set to grow strongly, and it's not a fashion, it's not a fad, it's being legislated. Just to have a look at this chart, this is, offshore wind turbine. You can see the forecast, and this is almost any analyst or any metals price forecast in the rare earth space. They're all forecasting a similar demand curve. And when you saw over here in 2022, earlier this year, that spike was late 21, early 2022. That was driven by Chinese, had a massive rollout of wind turbine power in China. And that put a lot of pressure on the neodymium, praseodymium prices, and we saw a price spike earlier this year. But that's just a small example of what can happen to this market. And there were incentives in China to get these wind turbines rolled out by a certain date. So there was a big push in China, and we saw that immediate push in rare earth neodymium, praseodymium pricing. But as I said, long term, this demand is not going away, and it's going to put a lot of pressure on these prices. You got electric vehicles, and whether it's a hybrid or plug-in electric vehicle, once again, that demand is not going away. There's various countries around the world that have legislated certain dates where you can't buy an internal combustion engine vehicle past a certain date. So this penetration might not grow as quickly as you see in the charts for various reasons like a recession, but the penetration is going to be there ultimately. In terms of supply, we know that there's a supply deficit coming, and that means we need rare earth projects to come on stream. And the supply deficit, as I said, has been driven by all the fundamentals. The macro is very strong. I don't think there's any other metal that's got a macro like these rare earth magnets. And as I said, we see that prices are going to increase to match this demand. Now to go into the project, Rainbow's project in Pelabor is in South Africa. It's a mining town, very far north of the country, 3 operating mines there. And what we've got is that we've got 30-odd million tons of gypsum residue, which contain rare earth elements in it. And the gypsum was the result of, you've got a hard rock phosphate mine next door called Phoscor, which produces phosphate concentrate in a slurry. That slurry was fed next door for 50-odd years to a phosphoric acid plant. The last owner was Sasol, the big chemical conglomerate in South Africa. And the phosphate slurry is your feed into phosphoric acid production, which you use in the fertilizer industry. So in the initial concentration process, your trace elements of rare earths and the phosphate hard rock are not economic. But because you've concentrated it in the slurry and fed it into the phosphoric acid plant, there are a couple of stages in the phosphoric acid production, and the rare earths were deported, slightly concentrated further into the gypsum, and now they reside in the gypsum. Very importantly, 2 key ingredients when you're producing phosphoric acid are sulfuric acid and heat. And all rare earth projects, hard rock or mine projects, have to produce a mineral concentrate, rare earth concentrate, then they crack it. And the two key things for cracking are sulfuric acid and heat. And this has taken place at Phalaborwa already in the phosphoric acid production process. So we start with a cracked chemical concentrate in these stacks, which is very significant as to why our capex and opex is so much lower at Phalaborwa. As you can see, our grade here is roughly about 0.43 to 0.45% total rare earth oxides in these gypsum stacks, and we've got about between these two 29% neodymium, praseodymium, one of the highest of any rare earth basket in the world, and we've got reasonable dysprosium and terbium credits. Now, mining projects, if you've got grade, it counts for a lot of, you can make a lot of mistakes if you've got grade in any mining project. So when we compare the Phalaborwa grade of 0.43, 0.5% to ionic clays, which is what they mine in China, we 6 to 10 times higher grade than an ionic clay deposit. Ionic clay deposits I measure myself against because they are very low cost mining, and at Phalaborwa we've got a very low cost here. We'll be hydraulically with water reclaiming these stacks, so we've got a very low mining cost, less than $1 a ton. And as I say, when you compare that to ionic clays, we don't have a mining cost per se, and that's why 6 to 10 times higher grade than ionic clay deposits. This is what really excited me about Phalaborwa. You can also see in situ value per ton in the gypsum. Multiply that by 30 odd million tons, we've got $5.5 billion of rare earth elements sitting in these stacks, already above the ground, no resource risk, no mining risk, and this is what I believe makes this a very, very attractive project. Going back to the normal stages of a rare earth project, you've got your mining, which is drilling, blasting, crushing, milling, producing a rare earth concentrate. Then you have to crack that concentrate, and then you go in to produce a mixed rare earth oxide or a mixed rare earth carbonate. At Rainbow, we are producing a separated rare earth oxides, one of the few rare earth projects in the world right now doing that. Lynas is in production, and they produce separated rare earth oxides. You've got Iluka in Australia, they're going all the way through to separated rare earth oxides, and there are one or two other projects around the world that are talking about going through to separated rare earth oxides. We are doing it. We've got a flow sheet that's been proven at lab scale, and we'll be building a 24-hour continuous pilot plant next year in April. It's my target to have it finished, and that'll just be to produce design data. But as I say, in one plant, we are going through all the way to separated rare earth oxides. We don't have to produce a concentrate. We don't have to crack it. Now, most rare earth projects do these in 2 or 3 different sites. And then if you look at Lynas, they ship their concentrate all the way to Malaysia. If you look at Pensana, they're talking about producing a concentrate in Angola and shipping it to Saltend in the UK. Makanga Resources are doing a similar thing. So Rainbow is quite unique. We're doing it in one place in South Africa, in Phalaborwa, and that also leads to a very, very economic project with amazing numbers. So if I go to our PEA, which highlights how good this project is, I don't think you'll see a mining project with these numbers anywhere in the world. So we've got a post-tax NPV of over $600 million at current spot prices for rare earths. We've got a post-tax IRR of over 40%, EBITDA margin of over 75%. This is why we are so cheap compared to the Chinese with that margin. And currently, if we built the plant today, we'd have a payback of 2 years. We've got a 14-odd year life of project in South Africa. But if I then use year-to-date prices, we've got an NPV of almost $1 billion. Our margin also increases quite strongly, and our payback is less than 2 years. So very, very robust project, which is very key in the rare earth space, because we see how rare earth prices over the years have fluctuated due to Chinese influence. We need to make sure we've got a robust project to make sure that the vagaries of pricing is not going to affect our project. We can survive a 50% drop in rare earth prices from where they are today, and we'll still make $80 or $90 million of EBITDA per year. And I don't think there are many rare earth projects that can do that. Just once again this is just in terms of our EBITDA margin. as you can see, as prices rise, our EBITDA margin goes up. I mean, if we look at forecast pricing, our EBITDA margin goes up to over 80%, and very insensitive to OPEX and CAPEX, this project. So we can withstand, as I say, changes in OPEX and CAPEX because our margin is so strong. And, you know, you can look at this presentation at your leisure. It'll be on our website. But, yeah, that just reinforces the story I'm telling you tonight. So, next stages for Rainbow. We've got a resource update coming shortly, and then we're going straight into a bankable feasibility study. Our PEA was a very, very high-level PEA. This is partly the background of Dave Dodd and myself, having done well over 100 feasibility studies between us, and I think they came through in the quality of the PEA that we delivered. As I said, we are, fortunately for us, this is a brownfield project, so Phalaborwa has amazing infrastructure. If I can just go back here one sec. So that's the mothballed phosphoric acid plant, and this plant has electrical reticulation. There's a high voltage switchyard at the base of the one stack over here. There's admin offices, there's machine offices, there's engineering offices, there's laboratory in place, there's 2 rail sidings, and all of that is available to Rainbow for this project. We will be demolishing the old phosphoric acid plant and building our plant on the same place. And what we'll be doing is we'll be building a new stack over here, and that stack will be fully permitted to EIA standards. And I mean, not EIA standards. For our EIA, will be fully permitted to Equator Principles standards and RFC standards, because when these stacks were originally built 50 odd years ago, there was no lining and there was no EIA to meet in those days. But now we have to meet these EIA standards. We've got acid water associated with these stacks from the phosphoric acid production. We'll be neutralizing all that acid water and using it to hydraulically reclaim these mining stacks, as well as using that water in a closed circuit. So we're doing a massive ESG cleanup of these stacks. So this project's got huge ESG credentials. We're neutralizing that acid water, and we're creating new line stack over here. And once that stack is full, we've start mining this stack first. We will then redeposit the balance of this stack onto this site, which will be lined as well. So we totally removing any environmental risk that this that site currently has with the seepage of acid water into the water system in this area. We've also got skilled labour on our doorstep. You know, most mining projects are around the world, even be in the outback in Australia or in the bush in Africa. You know, you've got to build clinics, you've got to build schools, you've got to build a huge amount of infrastructure. We don't need to do that as Rainbow, because it's all been built to service all the other 3 mines that are operating on our doorstep. We've also got engineering workshops in town. We're literally 5 kilometers from the center of town. Warman Weir, one of the largest producers of pumps to the mining industry in the world, they've got a depot 800 meters from our front gate. So, you know, when you've got plants in the middle of nowhere, you've got to have spares and strategic spares and so forth, which add to your working capital costs on that. This is greatly reduced for a project where we are. Just going back to, so being a brownfield site, most of our permits are in place. We'll be doing brownfield amendments to those permits. There's only one permit that we have to apply for from scratch, and that's for the new stack site. And that work's already started at Rainbow. And that's to make sure that I can keep my timeline in place. And basically, as I said earlier in my presentation, I'm looking to start our pilot plant in April this year. And with that, we will be looking at the bankable study being complete by the end of next year, end of 2023. We were looking to be financing the project in the first half of 2024, breaking ground in 24, commissioning by the end of 25, with production expected in 2026. If I look at forecast prices in 2026, this project will deliver EBITDA of about $320, $350 million a year. That means we've got less than a year payback on our plant. So very robust project. Our technology partner is based in America, K-Tech. There's a lot of information on our website, and our PEA can read about it. And as I said, very, very robust project. So the fact that we've got this unique IP in extracting rare earth elements from phosphogypsum, we're now looking at other sources around the world to do this. And we recently signed a deal with OCP in Morocco, the biggest phosphogypsum producer in the world. And they were on site earlier this month with me. And basically, we are moving forward with starting to run tests on their material and developing a flow sheet in conjunction with OCP on a commercial basis going forward. Very exciting project. Just the sheer size of OCP, I think the audience can draw its own conclusion. What an opportunity that is for Rainbow. Very importantly, Rainbow will be one of the only rare earth companies I'm aware of in the world that's got country diversification and project diversification. Even though we've only got a 14 or 15-year project life in Phalaborwa, OCP will give us a project with a life of 25 to 40, 50 years. And then also signed MOU with a major chemical producer in South Africa, also looking to extract rare earths from their phosphoric acid production, because that chemical plant uses the same feedstock that fed the original Phalaborwa opportunity they used down in South Africa. So we are looking at these other opportunities around the world, rolling out a pipeline of projects for Rainbow that will make us one of the key enablers of meeting the demand in the strategic supply chain outside of China. So I think we've got the right strategy, we've got an exceptional flagship asset, we've got the right technology, and we've got a pipeline for growth. Thank you.
Thanks, George. Thank you very much. Have we got any questions from the audience at all? There's a gentleman there by you, Peter.
Hello. Can you tell me how you'd be funding this?
We'll be funding this through a combination of debt and equity. We've already had the US government approach us last month once we released our PEA. They're looking at being one of the debt funders. We'll use typical mining project finance, and of course we'll use some equity. But by the time we come to raise equity, it'll be 2 years away from now. It'll be a different story.
Okay, anybody else got a question at the moment? Gentleman over there. Thanks yourself.
Hi. Has the design for the pilot plant been finalised, or is that still work in progress?
No, it's finalised, yeah. Yeah, we're just busy pricing it at the moment. I mean, it's been proven at lab scale, and all the equipment we're using for this project is commercially applied in mining projects around the world. So even though it might be, we've got a patent over our processing flow sheet, each individual part of that flow sheet, as I say, is commercially available equipment being used in commercial applications around the world. So we haven't designed a new reagent to use. These off-the-shelf reagents, acids, resins that you use in uranium plants, and CCl, which is counter-current leach. It's just big tankage, filter presses, but it's the sequence we're using them, and it's the way we're using the reagents is what we are able to form a patent over.
Hang on, Tel. This gentleman here first.
I could ask, a couple of weeks ago you published some information that seemed to suggest some sort of 2.5 billion of product in the ground.
5.5 billion.
Yeah, and your share price went down, and I wondered why you think that might be.
Well, we released a PEA 3rd of October. The share price actually went up 35%. If you look at the date of our launch of our PEA, also coincided with the largest redemption of by UK investors and funds in the history of the UK fund market. So we unfortunately have to release when my PEA is finished. I promised the market I'd release a PEA by a certain date. I couldn't delay that, and market conditions were terrible. So yes, it went up initially, and then the market took that as an opportunity to sell into the strength of the share. So we did come down after that. But as I said, it also coincided with the biggest redemption in history of UK funds.
Hotel. Yeah, that gentleman there. Thank you very much.
Yeah, I've got a few. So South Africa, what are you doing with your power risk? I mean, I know the grid is not so great there. Have you got enough power there? And then what about your political risk? Because again, it's not that stable. And then I know you said you've got everything on the doorstep, but are you doing anything in the community?
So let me just take the first question about power. This is not a power-hungry project. We need about 60 megawatts of power, which is quite low for a mining project, as anybody involved in the mining space will tell you. So we've got no crushing, we've got no milling and so forth. So 60 megawatts is quite a low power draw. We've got a power allocation there from Eskom. It's a brownfield site. We don't have to get a new power allocation. And we're in one of the hottest places in South Africa. At Palabor, we get temperatures of 40-odd degrees. So we're going to be putting solar in, but solar is not your base load. So we'll put in some gensets to support when Eskom is having problems, but power is not an issue, no. Sorry, the other one was sorry?
Political.
This is not a mining project, so there's no black economic empowerment in this project. It's a chemical processing facility on a chemical processing site. So we don't have any BE requirement in this project. And then you got to look at South Africa, you know. But if you look at political risk of mining jurisdictions around the world, it's high wherever you are. If you think Peru and Chile, two of the biggest producers of copper around the world, have got low political risk. You know, just recently we've seen what those governments have done to mining companies over there, companies like Rio, Anglo American, and so forth. So all mining jurisdictions have an amount of political risk. Even Australia, you know, a few years ago they just decided iron ore companies are making too much money and they decide to increase the taxes on them. So yeah, it comes with mining companies. And then in terms of the community, well, as I said, we will do, you know, we will be employing from the community. But we don't have to build clinics, we don't have to build schools, we don't have to do that type of community work because it's an established town with there are already schools, there are hospitals, there's clinics there. So we will be making sure we support local labour and we'll be during the construction phase as well as the employment opportunities that we will create here at site. We'll create about 300 odd jobs here.
Okay, any other questions at all? Okay, George, I've got a couple for you. You mentioned keeping costs down, that you can produce lower than China. How do you keep costs down?
Well, as I said, the reason why we such a low cost will be such a low cost producer is because we start 2/3 down the flow sheet of any mining project. So we've got far less steps before we start spending money, which is capex and opex, and we've also got one of your biggest opex costs in any rare earth plant is sulfuric acid. Mm-hmm. And sulfuric acid, if you've got a mine in the middle of Australia or you've got a mine in the middle of the bush in Africa, you have to transport that sulfuric acid many hundreds or thousands of kilometers. Fortunately for us, we've got Palabor Mining Company next door. They're a copper producer. They have a sulfuric acid plant because they've gone into the sulfides. They've just commissioned this new plant this year, and they'll have excess copper. So we'll be getting sulfuric acid. They'll produce excess sulfuric acid. So we've got a supply of sulfuric acid on our doorstep. We're taking their waste sulfuric acid basically at cost from them. So very, very cheap source of a key reagent. And as I said, we've got no mining costs. So we've compared to other rare earth projects, we've just got fewer costs and we can do it on one site. We don't have to send our product from one site to another site to go all the way through to separation.
Okay. Who owns the other remaining 30% in the Phalapuora?
It's a company called Bosveld Phosphates. They bought the project originally from Sasol. When Sasol were forced to sell this in an arbitration process in South Africa when they were deemed to be running a monopoly, and they were forced to sell this plant because by the Competition Commission in South Africa. And that was about 8 years ago. This plant stood for 2 years, and then when the new owners tried to restart the plant, it just kept having too many failures. Also coincided with the collapse in the phosphoric acid price because OCP in Morocco just came into the market and drove down the price of phosphoric acid because they're such a big producer, and basically they couldn't compete. So the plant never really restarted once it was closed down, and it's been mothballed since.
Okay. Any other questions at the moment? Did I see? No, I've got another one for you then. What are the demand drivers for rare earth?
So apart from electric vehicles, wind turbines, your cell phone, mm-hmm. One of the key things I think that we're seeing coming is that about a year ago, maybe 18 months ago, China announced that every air conditioner has to have a permanent magnet motor. Reason being, there are millions and millions of air conditioners produced every year in China, and of course they're a big power draw. So if you have a permanent magnet motor, you need less power, which means it's less draw, it's less carbon emissions. So it's to drive down carbon emissions. And we're seeing other countries realizing that things like permanent magnet motors are going to go to in a lot more applications. Water pumping, for instance. 20% of all the power around the world is used to pump water around the world. So if you now start having permanent magnet water pumps, you need less power for that. So there's lots of other uses for permanent magnets, and that's not going to go away.
So who will be your main customers?
We are hoping to be a key supplier to the Western supply chain, and we supply metal guys who take the separated oxides into metal and alloy, and they will then supply the permanent magnet manufacturers. And that's been rolled out at the moment. You'll see announcements coming very soon from major magnet manufacturers expanding in the US and in Europe, and those magnet manufacturers also need metal and alloy, and that means they need separated rare earth oxides. Neometals in Vietnam, I think it's Vietnam, they've just announced a big expansion, and they need separated rare earth oxides. So there's no shortage of customers for us going forward.
Excellent. Okay. Gentleman there, he's put his hand up. There he goes.
Yeah, this seems like a almost too good to be true project. And they always say that if it sounds too good, you've got to be wary.
Yeah, you're right. I said to my CFO, I said, when we launch this PEA, it's one of the problems we're going to have. People are not going to believe how good these numbers are.
Right, so you said that the demand for these type of materials is going to double, triple over the next 30 years. So there
More than,
even better. It's getting better by the second. What's to stop you doing nothing? What's to stop you from doing nothing, investing nothing, and seeing your assets, your reserves triple in value for doing nothing? And at what price will you sell out to the Chinese?
It's not a bad strategy. It'll save me a lot of headaches, I promise you. No, we want to be part of, as I said, the Western supply chain. I'm not saying it lightly, but I've got a history of building projects, delivering them. So I've got a good track record in doing that. So I'm going to build this. It's going to be commissioned, and in 2026 we'll be in production. But we want to generate revenue. Just to sit on an asset and to wait for somebody to come and buy it from you that's not a good strategy for any company, to be honest with you. And yes, the Chinese might want to come and buy it, but you've seen in Canada and the US strategic assets, the Chinese have been prevented from buying them. So I'm not going to rely on the Chinese to come and buy this project because they might not be allowed to buy it. So I'm going to build it.
Okay, thank you very much. I've got one more question over there, sir.
Hi. You said that there's investment coming in from the US government. I know before that it came in via TechMec, didn't it?
That's right, yeah.
Is there going to be additional investment beyond that, or is it just an expansion of what you announced?
No, I can't answer that. But all I say is that we did see the US government after our PEA on funding.
Excellent.
Yeah, that's all I can say.
Okay, George. Thank you very much indeed for your presentation.